Hello students, in this video I will be going through some exercises with you where I will be finding the area of composite figures. So it says here in the note that all figures are not drawn to scale. And what we need to do is we need to express the final answer in terms of pi as reduced fractions or in reduced radical form. And then for part B, it says to round your answers to the nearest whole number. I'm actually not going to do part B just because I feel like part B is just, entering into the calculator. So I will just figure out what the answer is, okay, from part A, which is just expressing the area in terms of pi or as reduced fractions or reduced radical form. Okay. So I notice here that I have a semicircle, because it says it, right, is attached to a right triangle. This is a composite figure, and we call this a composite figure because it's made up of compositions of different figures, different shapes. So much like a compound word, this is a compound shape. But we call it a composition of shapes. So I have a semicircle, okay, and the goal is to find out what the area of this thing is. Well, in order for me to find the area of a semicircle, I need to know what the radius is. So in order for me to find the radius, though, I need to know, I need to know this dimension here. I'm going to use a different color, actually. So I'm going to use red. So the height of this, okay, of this triangle must be 4 because this is a 3, 4, 5 triangle. And the height also happens to be the diameter of the semicircle, which means the radius then is equal to 4. Not 4, 2. Oops. If the radius is 2, then the area of the semicircle will be pi times 2 squared divided by 2. That's the area of the semicircle. The area of the triangle will be 1/2 base times height, which is 3 times 4. So if I put all this together, this is actually the area of this composite figure. This is equal to 2 pi plus 6. All right, moving on. Question 2. Here I'm told oh, I forgot, really important. My apologies. This is the units. The unit of the dimensions given here is in feet, so therefore this is going to be in feet squared. All right. Here I'm told the height of the triangle is 2 centimeters, which means that the radius will therefore equal to 1. And if the radius is equal to 1, then therefore the area of the semicircle is going to be this. The area of the triangle is 1/2 base times height. So what is the area of this composite figure? It's going to be pi over 2 plus 2. And all of this must be in centimeters squared. Let's find number 3. I'm told that this is an isosceles triangle because I see here there's a tick mark there and there's a tick mark there. And I have the hypotenuse given. So understanding this, okay, that the hypotenuse is 4 radical 2, right? And that this is a right isosceles triangle, and the right isosceles triangle will always have this ratio. Remember this from trig? So therefore, this dimension here must be 4. Okay, so if that's 4, that means the height of the triangle is also 4. And if the height of the triangle is 4, that means the radius is again equal to 2. The area of the semicircle is pi r squared divided by 2 plus the area of the triangle is 1/2 4 times 4. The area of this composite figure is equal to 2 pi plus 8. And the units associated with this is again centimeters, so it's centimeters squared. Moving on. It says here that the semicircle with a length of 6 pi meters. So that means this arc here has an arc length of 6 pi. If the full length of a full circle is 2 pi r, half a circle is pi r. Pi r is equal to 6 pi because I'm told this, right? So therefore the radius must be 6. And if the radius is 6, that means the height of this triangle must be, you guessed it, 12. The area of this composite figure, therefore, is going to be pi times 12 squared divided by 2 plus 1/2 2 times 6. I'm sorry, 2 times 12. Sorry, I made an error here. It's not supposed to be 12. This should be 6 because the radius is 6. Okay, so therefore, this is going to be 18 pi, because 6 squared is 36, divided by 2 is 18, plus 12. And this is going to be in units of centimeters squared. All right, moving on. I'm told that, again, this is a semicircle, and these two lengths are the same. The hypotenuse is 4. So if the hypotenuse is 4, and I don't know what this length is, let's call that x, and let's call this y, right? Because I'll need both of these. I can then say x over 4 is equal to sine 30, right? Because x is opposite of 30. And sine 30 is equal to 1/2. So therefore, x will equal to 2. I can do the same thing to find out what y is. I know that y over 4 is equal to cosine of 30. And cosine 30 is radical 3 over 2. So therefore, y will equal to 2 radical 3. So if I know that that this whole overall diameter is 2 radical 3, the radius therefore is going to be half of that. Half of 2 radical 3, well, that's just radical 3. So now I have everything, okay? The area is going to equal to pi times radical 3 squared divided by 2 plus, right, that's the area of the semicircle. Then we have the rectangle in between. So the area is x times y, right? So it's 2 times 2 radical 3 plus the area of the triangle. So the area of the triangle is going to be 1/2 2 times 2 radical 3. So therefore, if I were to simplify all of this, and all of this is measured in feet, by the way, then I will end up with 3/2 pi plus 4 radical 3 plus 2 radical 3. And all of this will further simplify to 3/2 pi plus 6 radical 3 feet squared. All right, moving on. Actually, I'm going to move this a little over because I have a feeling I may run out of room. Okay. So really similar problem. This one is actually slightly easier because if I know that this is 4, I can then figure out what these side lengths are, right? So if I know that that's an isosceles right triangle and I'm given the hypotenuse, okay, then therefore I can say that this is going to be, the ratio is going to be x radical 2. So therefore, what will x equal to? I will say x radical 2 is equal to 4, and therefore x is equal to 4 over radical 2. Remember, we got to rationalize, so I multiply top and bottom by radical 2. I end up with 2 radical 2 as x. So x is equal to 2 radical 2. Okay. So if x is equal to 2 radical 2, that means all of these are 2 radical 2, and therefore the radius is going to equal to half of that. So therefore radius is equal to just radical 2. Now I have all the information I need. The area of the semicircle, again, finding the area from moving from right to left, it's going to be pi times radical 2 quantity squared divided by 2, plus the area of the square in the middle, 2 radical 2 quantity squared, plus 1/2 2 radical 2 quantity squared. So what is the area of this whole entire figure? Well, I will end up with just pi plus 2 radical 2 squared is going to be 8, plus 1/2 of 2 radical 2 is going to be 4. So this is going to be pi plus 12 centimeters squared. All right, moving on. Semicircle with a length of 6 pi. This is all very, very, very similar. I think what I'll do is maybe do one of these problems down here and let you guys try to figure out the remainder of this, because I do have the answers to these, I believe. Let me take a moment, take a look. Let me see. Do I have the answers to these? Yes, I do. So I'm actually not going to go into too much detail in the other ones, okay? But I'm going to go over here and just maybe talk about it. Okay, so let's take a look at number 9, and then we'll do like maybe 2 of these types of problems, and then maybe 2 of these types of problems, okay? Just to give you guys a variety of different examples, okay? So the overall height of this is 10. The overall width of this is 6. So in order for me to figure out what is the area of the semicircle and the rectangle here, I notice that this is going to be 6. And if that is 6, I actually over-dimensioned this. So if that is 6... Oh, no. I did not over-dimension this. So if that is 6, that means this height here, the radius must be 3. And if that is 3, that means this overall height must be 7 then. So what is the area of this composite figure? Well, the area of the semicircle is 3 pi times 3 squared divided by 2 plus 6 times 7. So the area is going to be equal to 9 pi over 2 plus 42 quantity feet squared. All right. Next I have 6, and you're told that these are also 6. And if that's the case, then that means this radius must be 3. So the radius is equal to 3. The area is equal to pi times 3 squared divided by 2 plus 6 times 6. So this is again going to be 9/2 pi plus 36 centimeters squared. All right. Area of a rectangle is 25 feet squared. So this is 25 feet squared, and this rectangle, remember all squares are rectangles, but not all rectangles are squares. Remember that from quadrilaterals, right? The study of quadrilaterals. So if I know that this rectangle, which also coincidentally is a square, this side length must be 5 apiece. And if I know that the side length is 5, that means the radius, therefore, must be 5 over 2. And if the radius is 5 over 2, then that means the area of the two semicircles that I have here, I forgot to label these as semicircles, but these are semicircles. If I have two semicircles, that means that I have one full circle. So the area of the full circle is pi times 5 halves squared. That's the area of the full circle, of the two semicircles together. Plus the area of the rectangle in between, that's just 25. Well, that's just pi times 25 fourths plus 25. You can leave your answer like this, or if you want, you can leave it like this. It's all the same, to be honest. Okay? And this is going to be measured in feet squared, of course. Okay. The area of the semicircle is 36 pi inches squared. So if the area of the semicircle, that means this is 36 pi inches squared. So that means 36 pi is equal to pi r squared over 2. Right? So that means r squared over 2 is equal to 36. That means r squared is equal to 72. And if r squared is equal to 72, that means r is equal to radical 72. And if r is equal to radical 72, that means the height of the rectangle, right? Let's call this h, the height of the rectangle. H is equal to 2 radical 72. And if h is equal to 2 radical 72, I can reduce the radical 72 to become 6 radical 2 or 12 radical 2. So the area of this composite figure will therefore be 2 times 36 pi plus 12 radical 2 times 10. And this will be 37 pi plus 120 radical 2 inches squared. Let me see if that's actually the answer I got. Number 14. Looks like I made a mistake, so I will need to correct this on the answer key. Okay? So number 14. Yeah. Okay.